This is homework set 11 on factoring. We're going to take out the greatest common factor and factor by grouping. Question 1, we want to factor this binomial. Now, this is, imagine something's been multiplied out, and this is the product. What we want to do is undo that product, undo that multiplication, and get back to the factors. So look at what's common here. Any constants common between 3 and 5? No, nothing's common there. But look at the x's. I've got 3 of them here, 2 of them here. So there are at least 2 x's in each one of those terms. So I'm going to remove those 2 x's. Now, if I remove the 2 x's, what's left? Here's how I look at it. Look at this term here. Remove the 2 x's. Well, what's left? The 3 is left. All right, let me see if I can write it. 3 is left. And then what? Well, there were 3 x's. I removed 2, so there's 1 x left. Now, just run a quick check. X times 3x, x squared times 3x is 3x cubed. So we're back to where we started. Now, what about over here? There's a 5, and there were 2 x's. I removed both of those x's. So what's left? If I remove both those x's, there's that plus 5 left. So I'll write plus 5. And sure enough, if I multiply through, x squared times 5 is that 5x squared. So we've got it. So this expression here factors like this. Problem 2, let's see what we can do about factoring this one. We've got 2 terms here, 48a squared b minus 40ab squared. So first of all, look at the numbers. What is common between 48 and 40? And I'm trying to get the biggest number that I can. Now I notice 48, 4 goes into each of these, 4 goes into each of these. So I'm thinking maybe 4. But then I notice that I could take out an 8. 8 goes into 48 6 times. 8 goes into 45 times. So let's take out an 8. We'll go back and look at what happens if we take out a 4 in just a minute. But let's take out an 8 because that one works for sure. Now, a squared and a. There's 2 a's here, right? A times a. And there's 1a here. So there's at least 1a in each one of these. It's always going to be the term with the factor with the smaller exponent. So I'll take out an a, and b's, same thing here. I got 1b here, 2b here. There's at least 1, right? Smaller exponent. Now what's left? Think of it this way. 8 times what will get you to 48? So just reverse that. 48 divided by 8 is 6. Now I think of it this way. There were 2 a's to begin with. I removed 1. So there's 1 left. There was a b to begin with. I removed that, so that's gone. And now over to here. Now, 8 times what is going to be negative 40? Well, negative 40 divided by 8 is, I'll write a minus 5. Now, there was an a. We removed it, so that's gone. There were 2 b's, right? 2 b's. We removed 1. So there's a b left. And there we go. That should be it. Now, what if we didn't see the 8 and we just saw the 4? Well, what would happen is this. I'll take out a 4, and then I'll have the ab. Now, what's left? So think of it. 48 divided by 4. 4 will go into 48. 1, 2, 12 times. All right, and then I'll have what's left. There was 2 a's. There were 2 a's. We took out 1, so there's 1 left. There was a b, but we took that out, so there's no b's left. Now, what about over here? Negative 40 divided by 4. That's going to be a minus 10. There was an a. We removed that, so that's not going to appear. There were 2 b's. We removed 1, so there's a b left. Okay, now look at what we have here. 12 and a 10. There's a 2 in there. So I've got 4ab times, now I can take a 2 out, and if I take a 2 out, what's left? Just do it. 12 divided by 2 is 6a minus 5b, and then what do you get here? 4 times 2 is that 8, and there's our 8 right there. So we'll get there eventually. It just takes a little bit longer. Question 3, we've got a trinomial. Now, what is common? What is the biggest number that is common to 12, 16, and 28? Well, I can see that 4 goes into this, right? 4 goes into 12 3 times, and then 4 times, and then 7 times. So let's take out a 4. Now, what about these variables? I've got 3 x's here, 2 x's here, 1 x here. It's always going to be the smallest exponent. There is at least 1 x in each one of these. So I'm going to take out an x. Now, if I do this, what is left? Well, 12 divided by 4 is 3, right? So if I take 4 times what is 12? So just do a division. I'll get a 3. Now, there were 3 x's. We removed 1, so there's 2 left. And then, plus 16 divided by plus 4 is plus 4. There were 2 x's. We removed 1, so there's 1 left. And then, positive 28 divided by positive 4 is plus 7. There was 1 x. We removed it, so that's it. And I think we've got it now. Now in 14, it looks kind of big, but look at what we have here. I've got a 13. Now 13 is prime. Nothing's going to go into 13, so I'm just going to be stuck with this 13. Now, it makes you wonder, does 13 go into 156 and 130? Well, the 130 I can see, that's going to be a 10. But 156, get your calculator if you have to, and take 156, divide it by 13, and sure enough, you'll see that it goes in 12 times. So let's take out a 13. 13 is the biggest number we can take out. And variables, I've got an x cubed, 3 x's, 2 x's, 3 x's again. All right, so there are at least 2 x's in each one of these. Right, it's always the smaller exponent. There's 3 x's here, only 2 here, but 3 here, so there's at least 2 in each one. Let's take out that x squared. And then I've got 2 y's here, y squared, 2 y's here, 3 y's here, and 3 y's here. So there's at least 2 y's in each one of these 3 terms. So let's take out that y squared. All right, now doing so, here's what we have left. 13 times what is 13? We just do a division, right? There was a 13, we took it out, or 13 divided by 13 is 1. So there's just a 1 there. I'm not going to write the 1 in this case, but there are what? There were 3 x's. We removed 2, so there's 1 left. There were 2 y's. We removed both, so there's just an x left. And let's see, then we come over here. 156, positive 156 divided by positive 13 is plus 12. Now there were 2 x's. We removed both, so no more x's. There were 3 y's. We removed 2 of them, so there's a y left. And in that last term, 130 divided by 13 is a 10. Now there were 3 x's. We removed 2, so there's 1 left. There were 3 y's. We removed 2, so there's 1 left. And that's it. I think we've got it. You can always check it, right? Just multiply back in, multiply back in. Now, if you want to write it like this, if you want to write it as 13 x squared y squared, and then write the 1 here, perfectly good. Okay, writing that 1 there is perfectly good. 5, you can see these are getting a little bit longer, but they're all going to work the same way. What about numbers? What's common between a 6, 8, and a 6? Biggest number that divides all those is a 2, so let's take out a 2. Now what about A's? We've got A, B's, and C's. What about the A's? I got 3 of them here, 2 of them here, 1 of them here. So there's at least 1 A in each one of these. Let's take out the A. Now B's. I've got 2 here, 2 here, and 2 here. So they each have a b squared. Let's take out that b squared. And then c's. There's 1 here, 2 here, 3 here. So there's at least 1 c in each one of these terms. Now, what's left? Let's divide. 6 divided by 2 is a 3, right? And that makes sense. 2 times what is a 6? So let's just do a division. Now, what do we have for a's? There were 3 to begin with. We removed 1, so there's 2 left. B's. There were 2 to begin with. We removed both, so there's no b's left. And c's, there was a c, but we removed that, so there's no c's left. So we just get 3a squared. Now, next term, negative 8. Think of it as negative 8. Divided by 2 is negative 4, so minus 4. There were 2 a's. We removed 1, so there is an a left. There were 2 b's. We removed both, so those are gone. There were 2 c's. We removed 1, so there's a c left. And then finally, positive 6 divided by positive 2 is a plus 3. There was 1a. We removed it, so no more a's. There were 2 b's. We removed both of those, so that's gone. There were 3 c's, but we removed 1, so there's 2 left. So let's write a c squared. And I think we'll claim that that is the factored form. That brings us to the end of our first set of factoring problems in set 11.